Welcome to the ProSec Canin Instructional video. This is a tutorial on the half cell or potential field method. Here we can see that once corrosion begins, the cost of repair measures increases with time as the load-bearing capacity of the structure decreases. Under normal conditions, reinforcement steel is protected from corrosion by a thin passive film of hydrated iron oxide. This passive film is decomposed due to the reaction of concrete with atmospheric carbon dioxide, carbonation, or by the penetration of substances aggressive to steel, in particular chlorides from de-icing salt or salt water. The unprotected rebar is then subject to corrosion, which is an electrochemical reaction shown here. This principle creates a potential difference that can be measured by the half cell method. As the half cell probe is moved across the concrete surface, the variation in the potentials measured allows the localization of the corrosion hotspot. Typical orders of magnitude for these half cell potentials may give a quick indication of the corrosion status. However, for a more detailed interpretation, other factors have to be taken into consideration. Provided that the corrosion conditions are equal, the main influences upon the half cell potentials are moisture, temperature, concrete cover thickness, electrical resistivity of the concrete cover, and the oxygen content at the reinforcement. Another major influence on potential measurements is the electrical resistivity of the concrete. Low resistivity leads to more negative potentials and the potential gradients become flatter. Higher resistivity leads to steep gradients, and the measurement grid must be made finer in order to avoid the risk of missing an anode. It is therefore very important to measure the resistivity. This can be done with the Venner probe. A current is applied to the two outer probes and the potential difference is measured between the two inner probes. As we have already seen, when the electrical resistivity of the concrete is low, the rate of corrosion increases. And when it is high, as in the case of dry and carbonated concrete, the rate of corrosion decreases. Getting started. Here we can see the complete Canin instrument. An indicating device for display and data storage, a rod electrode which is a copper sulfate half cell, a one-wheel electrode, a 4-point Venner probe including the control plate, a 25-meter cable for connecting to the rebar, 250 grams of copper sulfate for the electrodes, 250 grams of citric acid for maintenance purposes, and a box with electrode cables and spare parts. In the lid of the case there is a wheel support including a path measuring system with cables, a telescopic extension for the wheel and rod electrodes, and a document box including the operating instructions, certificates, USB to serial converter, and a data carrier with the Canin Pro Vista analyzing software. When handling copper sulfate, be careful to take note of the safety instructions on the packaging. Preparing the rod electrode. Before filling, remove the cap with the wooden plug and soak it in water for about an hour to allow the wood to saturate and swell and to ensure a low resistivity contact. Prepare the saturated solution by mixing 40 units by weight of copper sulfate with 100 units by weight of distilled water. The electrode should be filled as completely as possible with a minimum of air in the compartment. This ensures that the solution is in contact with the wooden plug even when measuring in an upwards direction. To guarantee that the solution remains saturated, add an additional teaspoonful of copper sulfate crystals into the electrode. To prevent drying out, close the cap immediately. To prepare the wheel electrode, soak it in water for 1 hour. The wooden plug is not intended to be removed. Immerse the wheel in water well before you intend to use it to allow water to soak into the plug. The felt hoops and the felt hoop connector should be saturated with water to ensure a low resistivity contact before measuring. The electrode should be filled as completely as possible with a minimum of air in the compartment. And in order to ensure that the solution remains saturated, add an additional teaspoonful of copper sulfate crystals into the electrode. Close the copper sulfate compartment by using the Allen screwdriver included. Then open the water compartment and fill with water. For the 4-wheel electrode, each of the wheels should be prepared in the same way. To prepare the Venner probe, each of the 4 foam pads should be moistened with water. Now to the indicating device. Use a screwdriver to open the battery compartment and insert the 6 batteries, checking for correct polarity. Then close the battery compartment. Press the on-off key. The following data is briefly displayed: the operating mode, either corrosion analyzing or electrical resistivity meter, the instrument serial number, the installed software version, and whether the automatic self-test is OK. There is also an indication of the battery status. Performing a potential field measurement. Depending on the surface under test, it is necessary to choose which type of electrode will be employed. For small areas or areas that are difficult to access, the small and light rod electrode is the most suitable. For more accessible horizontal, vertical or overhead surfaces, it is much faster to use the single wheel electrode. For larger horizontal surfaces, the 4-wheel electrode is recommended for the reason of the significantly faster automatic measurement in a predefined grid. Use the profoscope to precisely locate and mark out the rebar grid. One of the rebars must be exposed for connection of the ground cable. In some cases, it may be possible to use existing building elements that are connected to the reinforcement, such as water pipes or earthing points. The connection should be tested for continuity. This requires at least one other point of the reinforcement to be exposed and to check the resistance between the two with an ohm meter. The connection should be situated as far as possible in opposing corners of the surface under test. The measured resistance should not be more than 1 ohm above the resistance of the cable used. The rod electrode connects to input A and also requires a ground connection. The wheel electrode connects likewise to input A, also requires the path measurement connected to input B and a ground connection. The Venner probe connects to interface RS232C only. Before real tests begin, a functional check is recommended. The probes should provide a stable value close to 0 when they are held in the air and a Canin Plus instrument is connected to Earth. It is also a good idea to make measurements on areas that are clearly damaged and compare them with measurements on areas that are clearly intact. For example, at the base of a column with obvious corrosion, compared with a measurement at the column at a height of approximately 1.5 meters without any visual damage. Here also, stable values should be obtained, whereby the measured values in the damaged area should be significantly more negative than the values from the undamaged area. A further check is to use a reference electrode. In this case, the rod electrode is used as a reference electrode and the potential of the two electrodes cancel each other out. For correct operation, the tolerance values of ±5 millivolts for the rod electrode and ±20 millivolts for the wheel electrode are acceptable. If the electrodes are out of tolerance, clean them. When preparing the test surface, it is recommended to mark out a grid on the surface corresponding to the grid you wish to use. It is always necessary to check whether or not a measurement can be made through a coating. To do this, potential should be measured at a few locations, in the first place through the coating and then with the coating removed. If possible, areas with largely varying potential should be chosen. If there is no alteration of the potential, or if the shift of the potential can be compensated by a correction, for example plus or minus 50 millivolts, then a measurement can be made directly on the coating. If not, then the coating must be removed before making the measurement. The contact between the pore solution of the concrete and the probe can be impaired by a dried out concrete skin. This can greatly increase the electrical resistivity of the concrete. It is therefore recommended to moisten the surface approximately 10 to 20 minutes before carrying out the measurement. If this is not possible, it must be ensured that the sponge on the rod electrode or the felt hoops on the wheel electrode are sufficiently moistened. Now to carry out the measurement. On startup, the measuring screen is as shown. Press Menu to access the main menu. Use the arrow buttons to select a submenu and enter it by pressing Start. Adjust the settings according to your needs. Pressing the End button saves any changes made and takes you back to the measuring screen. The Canin indicating device supports two different operating modes. It will start up in whichever mode was used last. For potential measurements, the instrument must be in the corrosion analyzing mode. Switching between modes is done in the Venner submenu. Select Venner probe off for corrosion analyzing mode or on for resistivity meter. The submenu display determines the grayscale values that will be used on the screen. The total range possible is between plus 200 and minus 950 millivolts. An optimal base setting is between 0 and minus 350 millivolts. The submenu object number is used to set the name for the file where the current measurement data will be stored. The submenu language sets the operating language which is valid for both potential and resistivity modes. In the electrodes submenu, set weigh encoder to yes for the wheel electrode and no for the rod electrode. Then select the number of electrodes, typically 1 for the rod electrode and either 1 or 4 for the wheel electrode. The XY grid menu determines the spacing between measuring points. The coarse grid menu determines how many times larger the coarse grid is than the XY grid already defined. This is useful for carrying out an initial sweep of a larger surface and then switching to a fine grid for detailed investigations of interesting points. The submenu data output is used to clear the memory and to reopen objects for display. Data transfer to a PC is handled by Canin Pro Vista. On the measuring screen, the XY coordinates are displayed in meters. The display has 16 points by 15 points, 240 points in total for displaying the measured values as a grayscale. This constitutes a page. With the XY grid set to 150 by 150 millimeters, as in the example here, this represents a total area of 2250 millimeters by 2100 millimeters. The cursor position, indicated by a cross, shows the location of the next measurement. Additional information is provided at the bottom of the screen. At the left-hand side is the meter value. For example, a 10 will be shown here if we have travelled 10 meters in the X direction. The box next to it shows the object number. Next to this there is a variable indicator which changes according to the type of electrode being used. To perform a measurement with the rod electrode, moisten the foam rubber plug of the electrode with water and press it lightly onto the first measuring point. The measured value will be shown in millivolts in the center of the display. Once it stabilizes, a beep will indicate when the measurement has been acquired automatically. At this point, the millivolt value is blended out and a grayscale indication will be placed on the grid. The cursor will move to the next point to be measured. Following the measurement, it should be possible to see a wet patch when applied on dry concrete. If this is not the case, then the foam rubber plug should be moistened with water again. When measuring with the wheel electrode, begin at the location corresponding to the top left-hand corner of the display screen. Press the Start button to acquire the first reading, and then proceed to move the wheel electrode in the direction indicated by the arrow. If this is down, or the Y direction, the measurement readings will be acquired automatically in the pre-selected row spacing. When you come to the end of a column, press the arrow right button to indicate this and the cursor will jump right to the next column. The direction arrow will automatically change direction to the up arrow. Now place the wheel physically one column spacing to the right. Acquire the first measurement by pressing the Start button and measure backwards along the Y-axis up as indicated by the direction arrow. Measurements with the 4-wheel electrode are done in exactly the same manner as with the single wheel electrode. However, in this case, the measurement along the Y-axis measures 4 columns at once. This is the fastest way to scan a large area. Existing readings can be overwritten by moving the cursor to the appropriate point in the display and making a new reading with the electrode. Once the reading has registered, the cursor will move to the next measuring point along the axis indicated by the direction arrow. To delete an existing reading, move the cursor to the point you wish to delete and press Print for 2 seconds. To carry out maintenance on the rod electrode, unscrew the 2 caps, wash the tube out with water and carefully clean the inner side of the tube. Clean the copper rod using an emery cloth. Then refill the electrode with the copper sulfate solution. To maintain the wheel electrode, remove the felt hoops and wash them in lukewarm water. Remove the plastic filling screw and pour the copper sulfate solution into a container for reuse. Flush out the compartment several times with water. Then dissolve 1 part of citric acid in 10 parts of hot water and half fill the wheel. Replace the filling screw. Leave this for 6 hours, shaking occasionally. Then pour out the citric acid solution and flush out several times with water. When not in use, store the wheel electrode with the wooden plug facing upwards. To carry out a resistivity measurement, connect the probe with the RS-232 interface of the indicating device. Moisten the 4 foam rubber pads with water. Carry out a functional check by placing the Venner probe onto the control plate. The reading shown in the actual window should correspond to the value written on the test plate. When carrying out a measurement, make sure the surface area is clean. As far as possible, reinforcement bars should not be directly beneath the probe and should not run parallel to the probe. The recommended procedure is to measure diagonally to the rebars. In order to ensure this, it is recommended to map out the rebar grid using a profoscope. Please be aware that the Venner probe constantly draws current. Only connect it while measurements are to be carried out. Before making a measurement, check that the display instrument is in resistivity meter mode by selecting Venner probe to on in the Venner submenu. In the device constant submenu, check that the code entered matches the code engraved on the Venner probe. The Data Output submenu is used to clear the menu and to reopen previous objects for display. This mode is also used to export data to a PC. When performing a resistivity measurement, the following information is displayed on the screen: the object number, the mean value and the number of measurements taken, the maximum value and the minimum value, the position in the table and the reading stored in that position, then the actual resistivity measurement and the proportion of current flow through the concrete relative to the nominal current. The cursor keys are used to select the position in the table where you wish to store the actual measurement. For reliable readings, it is necessary to have a good electrical contact between the foam pads of the resistivity probe and the concrete surface. The well-moistened probe should be pressed lightly against the surface of the concrete until the reading is stable. The current field monitors the current flow through the concrete. If there is a bad contact between the electrodes and the concrete, or if the conductivity of the concrete is small, the flow of the current will be reduced. This gives an indication as to the reliability of the reading obtained. For a current reading between 50% and 100%, the reading is reliable. If the current reading is between 20% and 50%, then a value not exact will be displayed on the screen. If the current is between 0% and 20%, the resistance is greater than 99 kiloohm centimeters, or the contact is very poor. Once the reading is stable, it can be saved by pressing the Store button. It will be saved in a table in a position indicated on the display. As a general rule of thumb from literature on this topic, if the resistivity is greater than 12 kiloohm centimeters, corrosion is unlikely. When the resistivity is between 8 and 12 kiloohm centimeters, corrosion is a possibility, and for resistivities less than 8 kiloohm centimeters, corrosion is fairly certain. When the measurement is completed, remove the foam pads and let them dry before putting them back into the case. Analysis of the data is carried out with the ProVista software. Connect the indicating device to your PC using the transfer cable and the RS-232 to USB adapter. In order to download data, the Data Output submenu must be visible on the indicating device. From the main screen in ProVista, click on the Vista Transfer button to start the download program. All of the objects stored in the display unit are listed in the field on the left. By default, all objects are selected for downloading. Use the checkboxes to select which objects you wish to transfer. Then push the button Save Selected in Vista Transfer and select the respective COM port. It may be that the objects measured on site were not all measured in the same direction. ProVista allows this to be corrected. Select the correct orientation for each object and press OK again to display the measurement file as a potential map in the main window. Here we see the potential map. The scale represents the dimensions in either meters or feet. The legend to the right shows the color coding of the measurement values in millivolts and the number of measurement points in each range. The three fields X max, X min, Y min allow the user to zoom in on a particular area in the graph. The bottom section of the window shows the positions for cursors A and B and the millivolt value of their current position. The grid direction values indicate the resolution of the measurement. The number range to which the colors are assigned can be changed through varying the base value and delta. Canin ProVista is used to estimate a threshold potential, below which it is assumed that the concrete is corroding and above which it is assumed the concrete is healthy. This threshold potential is a variable which must be determined for each individual concrete using statistical methods and also verification by further inspection. For the evaluation of the measurements, Canin ProVista offers two statistical presentations. the relative frequency and the cumulative frequency graphs. By use of these representations, an individual determination of the threshold potential is easily possible for each structure and for single sub-areas. With the relative frequency function, a bar graph of the measurement data is created. The width of the bars represents the measurement range, while the height of the bar represents the relative frequency of measurement points within that range. Once the relative frequency graph has been generated, it is possible to move on to the cumulative frequency graph. And this graph allows the placement of 3 cursors in such a way that they represent areas of different corrosion degrees. They determine, finally, the colour distribution in the chipping graph. It is possible to overlay 2 or even all 3 cursors and thereby decrease the number of divisions. The cumulative frequency needs to be activated at least once for a newly opened file in order to be able to view the chipping graph. Once the cursors have been set on the cumulative frequency graph, the potential map button becomes active. By clicking on it, the visualization switches to the chipping graph. The 4 color regions of the chipping graph are based upon the 3 cursor positions in the cumulative frequency graph. These positions represent potential limits identified by the engineer as areas of equal condition where the concrete has to be chipped to a certain depth for repair purposes.